I'm here at the San Diego State Lunabotics team, and we're going to be doing a live react to their test run at the Kennedy Space Center Visitor Complex for their mining robot. So Lunabotics is one of our Artemis student challenges, and it tests university level teams to design, build, and operate a lunar robot. So this year, as you can see, there's a lot of students that we're seeing on the screen right now. We had more than 30 robots mining in the simulated lunar regolith during this year's competition. So let's meet the San Diego State team. San Diego State is a Hispanic, Asian American, and Native Pacific Islander serving institution in San Diego, California. And they had a 10-member team. We have 3 of which are joining us today. Let's just go around the room and tell me your name, major, and role. Linda, let's start with you.
My name is Linda Clark. Like the rest of the team, I was a senior that just graduated, and my degree was in mechanical engineering.
Awesome. And what role did you play on the team?
Yeah, my role was manufacturing primarily, so making any metal parts or adapting any parts that we needed.
Cool. I'm really excited to see all your hard work in action with your test run. Alicia, how about you?
Hi, I'm Alicia Brunin. I'm also a newly graduated student from San Diego State. I got my bachelor's in mechanical engineering with an emphasis in bioengineering. And what I did for the team, I was our project lead or project manager, and basically leading the team up to keeping them on track for competition and all of our deliverables.
Awesome. Sterling?
My name is Sterling Belair. I was a mechanical engineering senior, and my role through the Hades project was the mechanical design lead, and then also just working with the electrical team and how we can interface electrical components with our mechanical components as well.
Sweet. I'm really excited to hear more about your roles and what they entailed as we talk a little bit more about your experience. But just for our audience, we're looking at the Lunabotics Arena on your screen right now, which is located at the Center for Space Education near NASA's Kennedy Space Center Visitor Complex in Florida. The arena that we're looking at was split into 2 test sites, Arena A and B. This is going to be important because we're going to be watching their test run with another test run behind it. So it's going to be important that we keep our eye on the right robot. And that just allowed for 2 teams to test at the same time. And you may have seen a different area a little bit earlier, and that was pit row. And that's where teams are working on the robots, watching other teams compete, and just hanging out. So I noticed you guys all have your team shirts on. I love to see you repping. Could you tell me a little bit about the name and what it means, how you picked it?
I'll go ahead and answer that. So our team name is Team Hades, which stands for Handy Aztec Digging and Extraction System. The Aztec is from our school mascot because we're the San Diego State Aztecs. And then digging and extraction, I think we will see later in the run that our robot is to dig and then extract what we're actually mining for. So yeah.
I love that. I love that you did a very NASA thing, which is make it into an acronym. That's like anyone who knows NASA knows we love our acronyms. And you also, I know you incorporated the Artemis program into your logo, which I really loved because that's the reason for the challenge. So it was really, really cool to see that. So obviously, I know we're seeing the site right now. What was the environment like once you got to the test site? How did you guys feel?
I think the environment was it was very high energy, but not in like everyone's yelling and stuff. But you could feel that everyone's brains were working very hard in that environment, and everyone was extremely focused on the task at hand and making sure that their robots were fully functional. There is a lot of that came with a lot of stress in the arena and area too. And then when teams weren't able to successfully have their robots move, then it was, you could see the sadness, like, the energy around them and no one wants to be in that position.
Did that
But
stress you out seeing like another team go through that and be like, oh God, I hope that doesn't happen to us?
yeah, definitely, because a lot of teams had problems with their robots. So it was definitely something that was in the back of our minds, I think. But trying to stay focused was a big thing, and everyone was really nice too.
Awesome. Well, your test run's about to start here. And I just want to point out for the audience, we'll be looking at the lower half of the screen. Once it comes up, we'll just make sure we're looking at the right robot, and you guys can correct me if I'm pointing to the wrong one. But the goal was to dig well below the surface. Yeah, that's you on the bottom there, right? Perfect. Awesome. Making sure we're all following the right robot. So the goal is to dig below the surface and collect as many rocks as possible and then deposit them in a collection bin. So for our audience, that's what we're going to see this robot accomplish. Can you all tell me, one, what we're seeing on screen right now, and where are you in this moment? Like, what are you doing at the time of this happening?
Wait, I can't see where I'm going.
You got the camera too.
Oh, I see.
So for me and Linda, we were actually in the arena. We were two of the three girls because we're only three girls on our team. All three of us, we actually placed the robot in the arena, and I think Sterling was actually in the control room, which we saw earlier with Jean and Josh. So
I'm not trying to do it.
Yeah,
Awesome.
I was in the control room with our electrical team. The two that were controlling it were John Michelle and Josh, and there was a lot of delay in the controls. So, we inched the joystick forward, and then a couple seconds later see our robot move in the camera feed, and then we're very, very careful with maneuvering it around. So here you can see John Michelle, who is I call him pilot, taking his time and being meticulous with his moves.
Yeah, that sounds really challenging. Like, you have to be really patient. Like, you're, okay, I want it to go, but it's not going, but eventually it will. Like, that sounds really, really stressful. Wow, okay, so we're obviously seeing your robot begin to dig now. Could you describe your robot, the components that went into building it and having it accomplish what we're seeing in front of us?
Do you want to talk about the design a little, Sterling, and then I can
Yeah.
talk about making it?
Sure. So I tried to, since we came from San Diego, we wanted to create it in a very modular design because we had to think about shipping, and shipping it as a whole robot would be more expensive. So considering our funds, we wanted to be able to take it apart and put it back together very easily. So that was one of the huge things that was incorporated into it. And then, so we wanted a robot that was relatively simple but really effective. So we used a scoop conveyor, and then each wheel has individual motors that were really high torque. So we were able to get we never really got stuck, and if we did, we were easily able to get out of it. So we have our extraction system, which is this belt with a bunch of scoops on it, and that'll plunge into the surface to get deeper. And it's dumping the regolith into a little bucket behind it, which has a sieve on it. So we want to filter out as much of the BP1 top layer as we can and get to that gravel. And electrically, there were a lot of components in that box. And sometimes you see the motor kind of stall and torque. It's because our motor it had a pretty low stall current, which I think in the long run kind of helped us because instead of tearing our robot apart, then it would have stopped a little bit and then inched back and tried again. And then Linda did a great job manufacturing a lot of our components, like our wheels and our scoops and the bucket that it was dumping into because for sheet metal fabrication experience.
Yeah, it was nice that our school was able to take advantage of the machine shop that we have on state, although we didn't have sheet metal capabilities. So luckily, outside of the school atmosphere, I'm actually a sheet metal mechanic. So
Wow.
yeah, that came in handy. I didn't expect
I was
it
going
to.
to say, it sounds like you have an advantage from the other teams. You just happen to have that skill set. That's amazing.
Yeah, so instead of having to pay an outside job shop or wait for somebody else's schedule, I was able to get scrap material or know what type of material to order and do all of the layout needed to make Sterling's designs come to light. And it was also nice because a lot of times we needed to modify things pretty quickly. So I was able to just change the design myself rather than having to send emails to a job shop again. So yeah, it was nice to just help the team out in that way and have that skill set.
That's amazing. So I'm sure there were, specifications that your robot needed to meet, and different components that needed to happen. Did you have to make any modifications or changes once you got there?
There was one very small modification we added, and that was a little kind of like a buffer in the collection bin. So when the bin goes up to dump, then all of the gravel would fall out, because in our first run that wasn't the case. But for the most part, then I personally spent a lot of hours during the design process, because I really didn't want that to happen, to where we get to the competition and then we can't compete because we're not in requirements. So at least for the physical requirements, everything was okay. And then electrically too, then our electrical and computer engineers were able to take care of the qualifications and make sure that we were ready to go as soon as we checked in.
So what was that like? I know you said it was kind of a minor change, but did you have to go like get supplies? Were you prepared for that? I know you said it was a modular design, but what was that like?
Yeah, we took a little team trip to Home Depot,
Okay, you
and
guys are laughing, so there's definitely a story behind this.
yeah,
I gotta know.
it was like we got to an Airbnb, everyone was working and we had a problem shipping our robot. Like, we flew in, our robot didn't make it. So
Oh my gosh.
we're going back and forth to the airport to check in to see if our robot finally came, and no, and then okay. So
That's like a next level of like baggage. You're tracking your baggage. Like, you're tracking your robot to make sure your robot landed and it wasn't lost. That
yeah,
sounds crazy stressful.
yeah, it was pretty stressful. And then putting it together, then we had issues at our Airbnb when we were trying to put it together. There was like wiring issues. But anyways, after our first competition day, a super long day, we go to Home Depot, and we're just looking around for materials that we can create this little wedge shape. We ended up using I think it was like a block of foam, and then these little aluminum square sheets that we could bend.
I
And we were
think
able
the best part was definitely the Home Depot employees, though. And they're like, "Oh, do you need help with something?" Expecting like a plumbing or electrical
Yeah.
or painting. And we're like, "We're building a robot. Could you help us with this issue? Can you think
We're
of any
building a
materials
robot
we
for
might
NASA.
use?"
Yeah, it's kind of high stakes here, people. That's awesome.
They were so great, though. There were two employees there that were like really helpful. They really helped the vibe. It was good.
That's amazing.
Yeah, so big shout out to the Home Depot.
So I wanted to point out, our viewers may have noticed that there is a robot that's down on the course. It is not your robot, just for the record. So you may see that robot on its side, but the Hades robot is the one still digging away front and center on our screen right now. So the rocks that you're collecting, those, for the audience, those simulate frozen ice under the lunar surface. So we would potentially be looking to potentially mine that ice in future Artemis missions. So thus the point of the challenge. Was there a certain depth that you had to dig to, or a weight that you had to reach, or anything like that?
Yeah, so the top layer was basically a foot deep, which is like this lunar surface simulant, this like super fine dust. And we only wanted what's below this little foot layer. So our requirement was that we dig for 1 kilogram of this simulated ice. But I think only 2 teams in the entire competition were able to do that. And one of them, University of Alabama. So
Wow.
requirement.
Congratulations. That's amazing. So speaking of accomplishments, what did it feel like? I know this is a later test run, you had multiple, but how did it feel when you first saw your robot moving and coming to life, if you will?
I know that I personally was in the where all the pits are with all the other schools. So I was watching it with everybody. I know Sterling and Linda, they were both in the control room, but I think from my perspective, it was really funny because most of the team and all the other schools were watching the big screens that they had out there. And then when we started moving, everyone was like, "Oh my God, yes, let's go." And it was a really fun vibe. That was really, really fun.
Yeah, it was great to see it move, but also since I was in the control room, I was like, "Wait, don't stress out the drivers. Like, they're driving, they're trying to think of everything." So I'm like silently dancing in the back.
And during our first run, me and one of the electrical engineers, Jackie, were in the arena. And when we're in the arena, we just kind of load the robot in, and there's, we can't really do anything other than stand and watch, as you can see the people in the bunny suits outside of the window in the frame right now. So me and Jackie were there, and then when we saw Hades maneuvering through the course and then getting to the extraction zone and then start mining, she looked at me and said, "I want to cry right now," because it was like nights up till 4 or 5 a.m., especially on the electrical side, as they were trying to debug in the weeks coming up to the competition. And Jackie especially, she actually wired everything correctly the first try, which is really insane and really impressive. And I know that she put a lot of work into it. So from a mechanical standpoint, we can design it and build it. So I think of it as like it's kind of the body, and the electrical side is the veins and the blood and the brains. So you really need both of them to be working, and seeing them work successfully together, and knowing that all the hours that you put into it were actually for something, it was pretty rewarding.
Absolutely. So huge shout out to Jackie and the rest of the team.
Huge shout out, yeah.
It's really awesome to hear you talk about it like
For
that.
sure.
So your robot seems to be doing really well traversing through this regolith. And the regolith is what Alicia was describing, that powdery like substance on top of the rock. What were some considerations that you had for your wheel design to make sure that it would be able to do that?
So they need to get their digging mechanism up.
So when designing the wheel, I was looking at just tons of videos of past robots that have competed in this competition, drawing inspiration from them, seeing what worked and what didn't work, as well as considering what we have the capability of, actually manufacturing. And then we also added, just before we made them, we added like rims on the outside, which I saw a NASA, I think it was called a Viper robot. There was a recent video on that, so I drew a little inspiration from that too. But I want to say that I think what really helped us was our motors that we chose. Our teammate Billy worked on sizing those, and kind of worked together and just put together like the worst case scenario of how much power we'll need. And each motor on the wheel is a motor that can pull a garage door.
Wow.
So
wow, I would never expect you would need that much force. That's wild.
Yeah, so we're like, hey, we don't want to get stuck. Let's just get some really torquey motors, and we were able to maneuver really easily around the terrain, which was super exciting because we never were able to test driving on such a like a fine powder.
So tell me what's going on here. I know we just watched you kind of collect your sample, drive it back, drop it off. So what's happening here?
If they get a wheel in that hole, there's no way they're getting out.
At least from a control room standpoint, we're able to make our dump, and then we wanted to get back to the same hole, so we didn't have to dig through the layer again. But because of that, latency that I was talking about, we're having a hard time. So we're like, no, forward, reverse, like turn left, turn right. Come on, get back to it. And then we saw there was like a minute left, and we weren't able to do anything. So I think in a second here, then we start just like doing little donuts or something. But
I was going to say, it looks like you're just having a joyride. You're like, okay, let's cover up our hole that we made, make it nice and neat, cover up our tracks. Like, it looked very systematic. So it's funny you're saying like it was actually an error, but that's awesome.
Yeah, because at one point we just, I think we realized there's no way that we can collect anything more. So let's just spin, do something. And I think here we tried to dig before we were at like the correct angle. So our scoops were probably getting stuck on our bucket.
Gotcha.
Or there was a rock stuck in there. I'm not sure exactly.
I was going to ask, like, it kind of looks like you're showing off the writing that's on your buckets, but I didn't know what is written on there.
On all the buckets, it's each individual team member has basically one or two at least buckets for themselves. Then on the wheels, we had all the mechanical engineering students and our faculty advisor, Dr. Schaefer, who was
Oh,
also,
everyone signed it?
yes, everyone signed.
Oh, that's so sweet.
Yeah, and the electricals obviously took the electronic housing box for sure for like their individual team signatures. So it was really cute in the end, and yeah.
I love that. Was there anything that was unexpected that came? I just want to say for our viewers, we're now looking at a different group, different teams, robot. Their test run has ended. Was there anything unexpected that kind of came out of this? I know you said the logistics were kind of crazy, like flying with a robot that was in pieces. But was there anything else that came up that you didn't expect to be a challenge?
Yeah, we had a router problem, which was
yeah.
And so during our second run, I was in the control room during that time, and that was like a very stressful situation because Josh was in there like in the terminal, opening and closing, restarting everything he possibly could, and then we realized we could connect to our router, and our router couldn't connect to Hades. Never happened before. It's never been an issue during the entire duration of the project.
Oh my
and we think,
gosh.
yeah, and we think it was because of the lunar simulant that was like in the air, like there was the static from the dust was interfering with the signal or got into the router. But I wasn't out there, but I think Alicia or Linda was there when another team like sold us their router. When do you want to talk about that?
I think I was trying to run around to get an Ethernet cable because we also wanted to see again if it was the same issue happens if we're connected by cable. I think I was running around trying to see if we could get an Ethernet cable from anybody. So, but I know that was Billy who asked to get from another team their router, and they just basically handed us. We said, "Hey, we'll give you $20," and they gave us their router. And another thing about the competition is too, if somebody has issues with their parts, one thing that they do is over the intercom, they're saying this and this university is looking for this and this part. If anybody, like the entire competition was really also not just the competitiveness, but also helping each other out, which I think was also really, really good to see this interconnecting environment. So.
Yeah, I feel it was really helpful also to have our professor there because when we ran into like some issues, he was able to have this outside perspective rather than us who we've seen this constantly every day and been stressing over it for so long and having fun. But he was able to be like, oh, did you think of this? And he was able to network with other teams. And when we needed those parts or needed things, he was able to help and be like, oh, well, I talked to their advisor and I know what they have. And that was really helpful to have him there.
Yeah, having an outside third-party opinion is a huge asset. This run that we just watched, I know it was a demo run, but it looks like it went really well. I mean, definitely in comparison to the other robot on the screen, but in general, it looked like you accomplished, what the goal of the challenge was. But what was the experience like for you to persevere through that obstacle you faced with the router breaking and then see the success in the demo run and see what you achieved? What was that like?
Especially as a first year team too.
Yeah, I think it was great that we were able to do the demo run because during the second run again was the router failure. So that's the last one where we were going for points, and the demo run was honestly just for us, for ourselves, and like for the next coming team from our university and possible other universities that are looking for inspiration for their own robots. But I think it was more that, working on this project for a year and then failing basically or literally the thing happened that nobody expected. Like the sentence "expect the unexpected" has a whole different meaning to us now. But seeing what we worked on for an entire year and finally having it run the way it's supposed to run and so beautifully, I think was just the perfect validation for everybody. The perfect cherry on top, perfect ending, perfect rounding ending.
Yeah.
So.
It sounds like such an emotional roller coaster. I know you all have mentioned how close you became with your team through this experience, and like rightly so. You've been through a lot. Do you think that contributed to your success? Are there any moments that you want to share that you shared with your team?
I think at least in the past couple weeks leading up to the competition were a lot of really late nights. Like I said, especially from the electrical and computer team. But we had pretty much our lab set up at like Linda's house because she was nice enough to let us use some of her property for like testing and building the robot, and we were able to do everything there. So I get there one day, maybe around like 11. Jean-Michel is still there from the previous night because he just like slept
Oh
on
my
the couch
gosh.
and was there. And it was like, yeah, me, Jackie, and Josh were up so late that we kind of were just standing there in silence, watching the sunrise and listening to a rooster go off.
Oh my
And,
gosh.
and
As you do. Yeah.
yeah, so they're like, so after that, they just started like, laughing delusionally from the sleep deprivation. And I was like, you know what? Even though it's really tough, I'm sure that made you guys a lot closer. And I think the teams in general, they operate a lot more effectively when people can trust each other, and when people go through really challenging things together. You build like a deep trust and a bond with each other, and that's something that is really needed to be a good team.
I love that, and I love hearing that, this will bond you for years to come. It just wasn't a one-off year, and now you'll never think about it again. I'm sure it'll be in your mind in future projects and future life experiences that you have. So I just wanted to kind of wrap it up with what advice you may have for other students who are looking to be a part of Lunabotics in the future.
I think one thing that I would have loved to tell myself is, you will be pushed during this project, but you'll come out so much bigger and stronger in the end. To like really just believe in yourself and like not talk yourself down out of something. So just trust in yourself and rise up to the challenge, and it will help you in the future, or even tell you what you want to do with your future career, like it did for me. So.
Yeah, that's massive. I hear a lot about like not self-eliminating, like don't tell yourself no before someone else can tell you no. Like push yourself to limit, step outside and challenge yourself. And so I love to hear that that kind of helped push you on your future career path. That's amazing. Sterling or Linda, did you have anything you want to share? Any advice?
I would say from a design standpoint, um, I heard or I saw somewhere that the first step in attacking a very challenging problem is to severely underestimate how challenging it's going to be. um, and and it's like, yeah, you gotta build a robot, and it's like, sure, like that'll be fine. And then after that, you go figure it out. And I think for students that want to compete in this, um, spend time watching as many other videos of robots as you can, and look at what designs work and look at what designs don't work. If you want to try something new, make sure you have the time to test it out, and the funds for it too. And also, the powder is a lot harder to maneuver over than it
You
looks.
need a garage motor.
Yeah, oversized
Pro tip.
definitely do that. Make a rugged design, have enough torque in your motors and good connectivity. You'll be solid.
Yeah, for mine, I'd definitely say communication or holding each other accountable, because I really feel something that could have improved us is in the beginning, we're sure we met as a team, but the mechanical team was so focused, okay, what's on the design and what are our deliverables for classes. And we kind of knew what the electrical team was doing, but not really. And then the last semester, spring, we really were holding each other accountable as a whole. And if we would have done that in the beginning, like hey, what do you guys need from us to start your schematics and start your designs, rather than finding out weeks later. That would have been good. So listening to the other team and working together on those integral components would have been good to start earlier on.
Definitely.
Well, I think you all had some great points. It's been really amazing hearing about your experience and your growth throughout this past year of working on building this robot and so much more. I just want to thank you all so much for being here with us today.
Thank you for having us.
Thank you.